Hello, my name is Aaron Shafawaloff. Let's revisit flow together, and I will introduce you to reason. First, an example with flow. Let's make a function that we can later annotate. It adds two numbers. It accepts two arguments, foo and bar, both of which we expect to be numbers. We will import it in app.js. And we'll use it to add 1 plus 1. Easy peasy. Now let's add the flow pragma. Now we'll annotate the function arguments, specifying these should be numbers. We'll add the flow pragma to app.js. Flow says everything's okay. But if we change this number to be a string, now we get immediate negative feedback. This type is incompatible with the expected parameter type. It should be a number. If we change both of these to be a string, and then re-annotate the function to expect strings, which concatenates, then we're fine. But let's put it back to numbers. Everything's a-okay now. So what is flow? It's a static type checker for JavaScript. We can annotate variables and function arguments, specifying the types they should be. Flow gives us coherence. It ensures that the code we have treats the data with the types that we specified. Fortunately, we don't have to specify the types everywhere. When we say a certain value is a string or a number, for example, Flow knows that henceforth, this should be known as a number or a string. Or if we add two numbers together, it knows that the result is a number. It has type inference. Some people think that the main advantage of a type checker is the reduction of errors. This is a big benefit. But the biggest benefit is real-time feedback, a very quick feedback loop. This changes the psychology of coding. You get instant feedback. You get a sense of confidence. This makes it easier, much easier, to refactor your code. I use union types and exact types a lot. Union types say, it should be this or that. Exact types say, it should be these properties, nothing more, nothing less. Let's demonstrate union types. We'll create a student type, which expects a role value, a literal value of student, a name as a string, and a grade as a number. We'll make a teacher type, which expects a role literal value of teacher, a name as a string, and no grade property. We will export a function that greets a person. We expect a person. Here's the union type, which is either a student or a teacher. Let's look to see what kind of person this is. If this person is of role type, a literal value of student, let's greet them a certain way. Hello, person's name. Your grade is person.grade. If this person is a teacher, we'll greet them more simply. Hi, person.name. Let's import this function into our app.js. Let's create a person that we can greet. Const.person equals, the role will be student, the name will be Aaron, and the grade will be an unrealistic 95. Let's greet Aaron. Everything's a-okay. Type safe. Let's lock down these types to be exact types now. This says these properties, nothing less, nothing more. Now if I change this person to be a teacher, I get immediate negative feedback from the IDE because grade was not expected on a teacher. If I change it back to student, everything's A-OK. You may have noticed the immediate feedback, the hints, the drop-downs. I get this through a package in Atom called Nuclide. It's a wonderful package put out by Facebook, used internally at Facebook. Sort of a one-stop shop for a lot of great things for development, especially JavaScript. I'll give you an example. Nuclide provides me an outline view of my code. Let's change canEdit to be a string. I get immediate negative feedback now. Flow type errors. I can go if I want to see what I affected, but Flow is telling me that this is incoherent with my code. But if I change it back to a Boolean, everything's okay now. Here you can see coverage, type safety coverage. I can click that and get a sense of where in my file I don't yet have type checks. I need more flow coverage. Sometimes we think about test coverage, but type checking or type safety coverage, perhaps we should think about that as important as well. Side note, one perk of using the Nuclide package is this wonderful interface for choosing which of the chunks I want to use in a conflict when I do a rebase or a merge. Atom IDE was recently released. It is a collaborative effort between GitHub and Facebook. Seems to be comparable to Nuclide, like a Nuclide for the masses. Many things are comparable and similar. Flow now has a linter. What's great about this linter is that it's type aware. ESLint, which we all love and use, gives us wonderful hinting, linting errors based on walking the AST, the abstract syntax tree. Flow's linter does not replace this, but it is a nice complement to it. Here we get to leverage Flow's existing analysis engine. We get type-aware lint rules that are flow sensitive. You can turn this on in your Flow config file by setting all to warn under lints and include warnings to true under options. Let's demonstrate the use of Flow's linter. If we change the grade property into a maybe type, which it means it could be a null value, it could be undefined, or it could be a number. Terrible. We don't want to type coerce null or undefined to string, as though we could. So what do? We could do a simple existential check here for person.grade. But Flow's linter says this is a bad idea. This is a sketchy null check. Grade is a number. It could be a 0. We'd want to show 0. But that's falsy. What should we do? We should be more specific. We could do a loose not equals check against null, which here covers the circumstance of undefined. I like to do an explicit positive type check even better. Let's check specifically to see if it is a number. If you have to do an existential check, you might as well check the type. Flow's linter has changed the way I code. Wherever I need to do an existential check on a property, I go ahead and do a runtime check of its type. Flow now has better support for React. It also has updated the signatures. Let's demonstrate. Let's create a greeter component. Let's start with the Flow pragma. Let's include React so we can use JSX and extend the React.component. We'll call this the greeter component. It'll be simple. We'll have a render method that returns a div with this.props.message. Let's specify what message should be in a type definition. This message will be a string. Let's tell Flow what type definition to use for props. If we had state, we could add it here, but in this component, we're not managing state. Let's include our greeter component in app.js. Let's use it now. We'll send a property of message to the result of greet person, which returns a string. Everything's a-okay. Let's lock down our props definition now. Nothing more, nothing less. But if we add an extraneous property in our usage of this component, we get immediate negative feedback. Uh-oh, this was not expected. If we remove it, everything's a-okay. If we send a number for message, we get an error. It expected a string. Ah, that's better. If you use higher order components, or you need to do type annotations on, let's say, the children prop, you can use these types. Flow now gives us more types to work with when we're doing type annotations for React stuff. The creator of Flow says they're exploring a system of trusted types. Types that aren't sound could be marked as such, so that something like an optimizing compiler, perhaps here a Babel transform, would do validation, runtime checking against a type. This is exciting, but it kind of speaks to Flow's present inadequacy. Flow can give us a sense of coherence with our code, but it can't actually guarantee the type of data that comes from the outside of your app, or from the DOM, or whatever. Flow can't guarantee its types. Flow seems to add noise. It adds more to look at. I've used Flow 3 separate times, and the first two I've backed out. I've stripped out all the type annotations. But as my projects grow, what seems like noise ends up becoming more signal. In my cost-benefit analysis, Flow ends up being worth it now. It provides me a sense of security. It gives me a better overview of what my app does. It gives me the ability to move quick and refactors. If you were to drop in on one of our projects, I would want you first to look at the key data structures of our applications. This is even more important than other parts of the code. I might have you look at a set of type definitions, or if you're looking at the top of React components, I'd want you to look at the props and the state. Gives you a good sense of what's going on. Flow, React, and Reason have an interesting relationship. Flow itself is implemented in OCaml. Jordan originally prototyped React in standard meta language. He then moved it to OCaml, and then he transcribed the prototype into JavaScript for wider adoption. Facebook is now working on a syntax over OCaml called Reason. Reason is a new syntax and toolchain that is powered by the battle-tested language OCaml. This has a familiar syntax that's geared toward us JavaScript programmers, and it caters to the existing NPM and Yarn workflows that we already know and love. Reason can almost be considered as a solidly, statically typed, faster, and simpler cousin of JavaScript. Plus a lot of cool stuff. It helps you tap into really solid ecosystems. So, Reason's learning curve. It's meant to be comparable to learning JavaScript in addition to a gradual type system. So if you're going to learn JavaScript and Flow, it makes you think, why not just use a statically typed, sound, compiled language like Reason, or perhaps like Elm? OCaml types have 100% coverage, they do have inference, and they are sound. As noted, Reason's syntax is very familiar to JavaScript programmers. Here, though, you'll see that the operators are specific to types. There's no type coercive funny business going on. Now, Reason can render to JavaScript through a project called BuckleScript, but can also render to native code and be extremely fast. There's a lot of neat possibilities and opportunities here. Facebook is experimenting, pushing Reason. It's using Messenger.com as a kind of guinea pig for this. They've converted half the project to Reason. They have a blog post about it, and they speak in glowing terms, and they're trying to integrate Reason in other projects at Facebook as well. It's a project worth watching. You can check out Reason scripts, which is comparable to Create React App. Excuse me. You can check out the Quick Start Guide and learn more about JavaScript interoperability. Final thought. Do you think about linting, formatting, code analysis, type safety, compilation? Sometimes it feels like in the JavaScript ecosystem that a lot of these things are an afterthought. So, Reason has a lot of promise because all of these things are really tightly and nicely integrated in a more unified whole. Thank you. Again, this has been Aaron Shafawaloff. Thanks for listening to a revisiting of Flow and an introduction to Reason.